and I'm back online. And this time with sound. For the second time at least, I went on and rambled on and realized afterwards, because my friend told me that there was no sound on my stream. And that's because because although I'm monitoring sound, sound is going out. And if I monitor the what's going out on the stream, I actually get latency. And latency in my headphones while I speak is really, it's really not nice. So instead, I get it from the source, and so I get lulled into the illusion that the sound works because I hear it, but it wasn't. So I think I should make a note of this. How to avoid streaming without sound. I mean, the simpler answer to that is a checklist, right? That's how people do it in planes, even to this day, right? So. But we did some of our, I mean, what I did in the previous, oh, cool. What I did in the previous stream was follow up on this issue that I noticed in the PureScript strings library, where the documentation for, well, probably for a lot of things, but specifically this singleton function was not up to date with the documentation that you could actually see in the code. And that's because, well, I guess the docs weren't pushed properly onto this documentation website, Pursuit. And last time I streamed, I made I created an issue on the repo saying, hey, you know, documentation is not synced, and got the reply that I could push the doc myself. But I did try when I first encountered this, and then it was kind of tough for a number of reasons. And so, well, when Jordan here told me that I could push the doc myself, I tried again, and I went a little bit further forward on the problem, and that's what I did on the stream number 5 that I published today, and that didn't have sound. And it turns out that people came to my rescue. I mean, hopefully. So let's see. Looks like you should use 2 enum now. Yeah, no, that I understand that. Code point must lie within a valid range. Also, when pursuit is out of date, you can use starsuit, which shows documentation for the package set. Okay, I didn't know that. But that's not an answer to my question, but hey, Thomas Honeyman shows up. Hi, thanks for taking the time to try and publish this library. We're unfortunately in a transitional period with regards to packaging and library publishing, which is why you're running into issues. Typically, as Jordan Martinez mentioned, anyone can upload documentation for library using pop publish no push on the tag that's missing upstream. Yeah, right now you're having an issue because we're switching from Bower to our registry to our own PureScript registry. Bower files which are using git blah have been updated to use HTTPS blah, so the documentation can be published. Irritating. So yeah, so for the time being, I recommend using starsuit. Okay, so it's just something that's happening community-wide, and it will evolve. And right, starsuit is actually from with the new tooling Spago, and so I should use this instead of Pursuit. So that's, I guess I've learned something important, and so I will pop back the stack on this and remove the PureScript strings library from our focus, and I'll just say thanks and leave it there. And good luck with the transition. Okay, and not save, but command, and there we go. And I can therefore close this, in fact. Okay, good. So I'm glad to hear that tooling will be aligned with Spago, which is the thing I know, and I'll keep an eye on progress with that. It's going to take me a while to get used to not use Pursuit for documentation, but let's keep this open for now and go back to our main focus, Chronofolds. So, just as a little reminder, Chronofold is a data structure for version and real-time syncable text that came out in a paper earlier this year, and we've been trying to implement it in PureScript for a few streams. I mean, the first couple of streams were mostly trying to read the paper and trying to understand what the data structure proposed were. And then finally, after getting some first level of understanding of it and writing many comments in the source code, started to actually implement part of it. And where we got is the ability to, well, just as a small reminder, what we have is an array, a chronofold, which could also be called a thinned chronofold, because that's already sort of an optimization on the data structure that's proposed earlier on the paper. And then later there's some optimizations that are proposed, and that leads to basically the chronofold being only an array of code points. Values here are just a new type for code points. And then we have a couple of what's called co-structures, and one of them is next, which represents what is the next character in the string. And so that's sort of a linked list. And then we have an index and a reverse index, and the index maps a timestamp to an index. And so a timestamp is really it's basically what I've been calling a global coordinate or shared coordinate. And that's in contrast with the index here. So T here that I noted, alpha something, is a shared coordinate and it's a timestamp. And then NDX is really just a local index. So we have this local coordinate or local index in the data structure, which represent that if I am replica alpha, if I am process or computer alpha that's storing my information, then at index 1 of my data structure, I have this timestamp. That's what the NDX data structure does. And so if I receive a beta 1, for instance, and that's the 7th thing I received, then it will be indexed locally for me, it will be at index 7. And I annotate it with alpha here. And there's this other useful representation here, which shows like the PINSK, there would be a thinned chronofold, an array of code points, so Unicode values. And the alpha underneath would be that global coordinate system. And then the number at the top is the index, so the local index, so the local coordinate. And I annotate it with alpha afterwards, which is not done in the paper or in the still graphic here, but that I find useful to think about this. So, for instance, it tells us that when we receive beta 1, for instance, from a remote replica beta, we are putting it in our index 7 inside our local data structure. And so we need to have the index co-structure that goes from timestamp to index, and we need the reverse one, which is basically allows us to convert between this shared coordinate system to our local coordinate system. And that's one of the beauty in this data structure, is that different replicas, and so that's an example here, for instance, at the end of all of our juggling here and merging and whatnot, which I'll get into later, our 3 data structure, alpha, beta, and gamma, actually sort of look like are different on each replica. So gamma, as you see here, says alpha 6 and then gamma 14. So that's here, alpha 6, gamma 14. So it has a number of things that are alpha up to 6, and then it has gamma 7 to gamma 14. And then it has beta 7 and beta 8. So it's alpha 6, gamma 14, beta 8. Whereas on beta, we have a different order. We have the beta stuff that comes before the gamma stuff, because it's all in the order in which it was received. But the beauty of this algorithm is that despite the fact that things will be ordered differently in each replica, the algorithm knows how to produce exactly the same result on all replicas after they've received all of the data there is to exchange. So that allows us to have what's basically a conflict-free replicated data type, and that's this whole domain of research that Chronofold fits into, CRDTs or conflict-free replicated data types. Okay, so we have a few other things in the data structure like refs, which help in determining whether we have a conflict or not and how to solve it. And so that's called a preemptive CT sibling. And I don't know whether we get to this today, but that's one of the next things we need to implement. What we have for now is just a way to append operations onto a log. So a log, as I defined it here, is this ensemble of all of this data structure, the thin chronofold, this array value, all of the code structure, the index, the reverse index, the ref, and all of that stuff. All of this is packaged into a log. So we see it here. And I also added the current timestamp to the log so that we can follow where we currently are, and so that we can increment it properly. And so to put it in terms of this diagram again, a log will be basically this whole sequence, and each replica will have its own log, and it can differ by ordering, as I mentioned, but we know how to render them to the same final result. So that's one of the other things we can look at, because right now we've only built tooling to display the whole log and its guts, its internals. And I can show that, Chronofold and Spago run. When we run some of this test code that I have here, we output alpha log Pinsk, which is this whole log, which has this timestamp and the array, the thin chronofold, the array of code points, and the reverse index, ref, and all of that stuff I was showing. But that's not what we want to display on screen ultimately for a user of this data structure. What we want is to display the resulting string with all of the edits. And so one of the things that I was thinking about was the representation of the backspace value, which is why we were actually commenting on the strings library in PureScript, is that I was just wondering, how do we get a backspace character? And so I believe that now we can say this by using the backspace Unicode code point instead of this trick here. And then I want to sort of first of all figure out, how does showing a string which includes a backspace, how does that even work in PureScript? So I think that the result of mapping will give me a string here. So I think I should be able, so let's call this backspace. Backspace equals this. So now I believe the type of backspace is a string. And we can probably validate that by doing, can we do this? Maybe string. So cool, maybe string. Since we know that this is a this is actually a string because we're passing it a constant. We can do maybe and we can pass, let's say, the empty string and id for transformation, and oh, it's not id, it's identity in purescript, and now backspace should be a string. Oh, A has infer type string. Yeah. So now we can concatenate it and say something like, well, say something like Pinsk and concatenate with backspace, and how about we do it? We make 2 backspaces, and then we put K. So that should give us pink. With it? No, it writes the backspace character. So that makes sense, and I just don't know how it means that so I mean, my question is what will rendering look like? I guess it's at the show instance level of I'm not sure how I have no prior knowledge of how this is dealt with normally in programming language and even in editors in general. I would think that usually when someone hits the keyboard backspace, usually you don't add a backspace Unicode character. Usually you actually just delete the stuff. But here, because we need to record that backspace in our log locally to send it around and all of that stuff, we obviously need an intermediary step. And so I'm not sure what this means in terms of data structure. I'm thinking maybe I need a data structure that would be my rendered string. And I need to be able to convert from my log to whatever representation we want to display something on screen, right? And so I'm not even sure. I mean, I guess we will have Chronofold depend on the strings library. That sort of makes sense. But if we want an efficient representation, then it should be something like a byte string, really, not a string. And we should update it in chunks and all of that stuff. Things are coming back to me a bit, but let's see. Pure script. What's the byte string type like? There's byte strings here. Hey, starsuit's coming up as a thing, and here, yeah, that's probably better to use that. And do we have string to byte stream conversions, and how would that even occur? Well, we have toString and we have fromString. Yeah. So what's the overlap between byte string and a code point or some Unicode representation? There's no such thing. So, well, I guess if we pass it the proper encoding, let's go to GitHub here. Immutable packed byte sequences, similar to the Haskell byte string package. Tools? What's tools? CodeGen. Interesting. Let's see. Oh, I'm supposed to have music playing, but I don't. And it seems to be playing, but I'm not hearing it, so I need to change something about monitoring, I suppose. Desktop audio, monitoring and output. Check 1, 2. Okay, I just had my monitoring set up incorrectly, but hold on. Yeah, no, that's still incorrect. Sorry, that's a tangent. Monitor. Okay, I can't do this properly. Check 1, 2. I'm just hearing the right. So check 1, 2. Still not. Okay. I'm gonna hope that the level is not too bad. And I'm gonna write this as something to explore when I look into tools. So it's not gain control in sound, like there's still some problem with routing there. And monitor pretzel. Okay, let's come back to byte strings. UTF-8. In fact, it's not even clear that I should use pure script strings, because maybe I want the internals to be manipulated by manipulating byte strings. maybe that's premature optimization at this stage, especially because I haven't done that before. And the other thing that's lingering in my mind is the fact that backspace, I believe, is a tombstone and is actually this character here. But I'm not entirely sure of that. Maybe I should search for tombstone in the paper. Deleted characters get marked with tombstones. Yeah, so OT with tombstones, tombstone with no tombstone. In an extreme case, if the history of a document is discarded entirely, then the text represented as a single sequential insertion with no tombstones. Yeah, I think of this a little bit as garbage collection. It's like, if you don't need to access the history, then you can make a pass that's sort of going to compact and remove all tombstones and remove all text that doesn't need to be, you know, undoed, let's say. So, yeah, something else in the sound that I'm noticing in my headphones is that I hear a buzz. Buzz, and that might be the auto gain. That means that I'm hearing the buzz when I speak and that it's actually always there, but there's a buzz sound that I need to troubleshoot. Okay. So maybe we're okay with code points as it is for now. We might want to, in the later iteration, transform, receive byte strings over the wire. Those ops are going to be sent over the wire. I think they should be, you know, JavaScript, what is that called? Buffer arrays or type buffers, typed arrays, whatever is the quick thing. And we'll play with different representations, I think, and then we'll receive that sort of pack serialized representation over the wire. We would then store it, append, hopefully doing append only work locally as much as possible, and then we'll need to call the rendering to string, to the final string. So there is a kind of a interpretation pass, right, of the log. Maybe calling it interpret log, or it's also a projection from the event sourcing standpoint. So maybe let's call it project. Project log to string. And it's like interpret the log into a string. And maybe in truth we'll want to project it to something else, like project it to a JavaScript typed array. Is that what I'm thinking of? It's a type array, right? Yeah, I think that those are the ones that are fast. Yeah. And I mean, this could be called to a string. It's all good. We can think of it as a show instance as well. Sort of. But maybe we'll want a project log to typed array of some sort. And maybe we'll even want that to sort of be in the GPU somehow. but right. And the other thing is that in fact maybe we'll want a diffable project, or incremental, where we sort of have a delta log, or sort of maybe an op, or maybe even an array of ops. That's also cool. To some kind of mutation over the typed array. So maybe a st monad or something like that. But that's for the future, right? Right now, can we write a project? I mean, we can write a naive project that's just going to take the, let's write the simpler project. It's just going to take this array of code points, CPs, ignore all the rest, and then do, what is it? Code point, whoopsie, code points, I think, and that's right. Non-empty code points. Well, that's good enough. Yeah, maybe, sort of. Oof. Sort of, huh? Search is not working properly, in fact. So we have an array of code points, and we just use from code point array. How about that? From code point array of CPS, and we should be good to go, no? Ah, right. We just need to fmap it and throw away. So we need to kind of unwrap it, really. That's what we want. And it is a new type, so I just can derive, or yeah, I think I can derive new type, can't I? Let's see, value, boom, boom, boom. Array value, yes, and value is this. And can I think I can derive new type value as new type value, and I think I need to have some kind of carrier thing, and those classes type. Is it maybe new type like this? Oopsie. Yeah, that's the one. Okay, and so I should be able to use unwrap now, except I need to import it. Yeah, and seems to type check, right? No, not something doesn't. Cannot derive the new type class instance. Okay, let's see how it's meant to work. Pure script new type. Here. It's not a new type deriving thingy. That's the whoopsie. Oh damn, what did I do with my tiling? Okay, and let's put it in this order, and then what? Then unwrap works. It doesn't. It doesn't because I whoopsie. Because I do need to fmap. So I think it means I need to do this, isn't it? And I just need to import this guy from Prelude if I can. I can't. Is not in Prelude? I think it is in Prelude. What? array string with string. Oh, because from cut pointer, yeah, I don't want from cut point array. I want something that gives me back a character. I could then append, I suppose. Maybe this whole value thing is just a bad idea. And so let's just not do that. And let's just put a code point in it directly and use the refactoring superpowers of a strongly typed functional programming language. We don't need a constructor here. We're not going to need to unwrap. And it compiles. Wow. I'm surprised actually. I thought that I would have other value constructors sprinkled around, but oh, I had it in my test, but not in my code. Beautiful. Oh, that was fast. And so are we done? Then do we have project and it works? Let's try. Let's try to log show alpha log sphinx, but also log show, or in fact just log, which we need to import from effect console. Is good, and we run. It does work. So obviously this is a naive thing. It doesn't do any of the resolution, but it's good. And let's try it with, let's say, this guy, which will also allow us to get rid of this and this and this. And then let's also log alpha log 4. Let's see what this shows us. I think it should be PII. Yeah. Okay. So that works as expected, but it's only for a single replica, so it doesn't do any of the actual merge algorithm that we want to implement. So now we can project, and so what does it mean for backspace, and how is that dealt with in general, I wonder? How does a text editor render backspace? Build your own text editor. Backspace. If you press key backspace or enter, those characters will be inserted directly in the text, which we certainly don't want. So that's okay. Let's see. If you look at the ASCII table, you see that ASCII code 8 is named BS for backspace, and ASCII code 127 is named DL for delete. But for whatever reason, in modern computers, the backspace key is mapped to 127, and delete key is mapped to escape sequences. You gotta love computers. Okay, so that's not gonna help us. And Unix erases things when you type a backspace while entering text. Printing a dull character doesn't actually erase anything. This raises an interesting question, because when you're typing something into Unix system and hit your backspace key, Unix sure erases the last character that you enter. So I was doing that. So it turns out to be basically what you'd expect, although the actual implementation rapidly gets complex. When you hit backspace, the kernel TTY line discipline rubs out. The TTY line discipline runs out your previous character by printing Ctrl-H, a space, and then another Ctrl-H. What? In Unix kernel source code, you generally see this using not the row byte value, but the C escape sequence for Ctrl-H, /B, which we see here, in fact. Printing Ctrl-H is not the only use for /B, but it's certainly one reason it's one of the few control characters with one CF. Of course, just backing up one character is not always the correct way of erasing input. But you haven't talked about backing up yet, even. Okay, what happens if I do Ctrl-H here? It does backspace. I see, Ctrl-H, a space, and then another Ctrl-H. Huh. I see. Now it makes sense. Of course, just backing up one character is not always the correct way of erasing input. That's when it gets complicated for the kernel. To start with, we have tabs. Yeah, because when you, the user, backspace over a tab, you want the cursor to jump all the way back, exactly, not just move back one space. So let's try that. Test. Okay, well, I can't tab properly here. Let's go in bash, see if we can. That's in a virtual machine? Holy moly, I had no idea. It must be part of the Windows subsystem for Linux. Test. Well, tab doesn't work either because it's autocomplete. Do we need to do test? Yeah. Oh, we can't tab out in here. Can we tab in? Well, VI won't make sense, but there is Vim here too. Okay, let's try and understand. Start, we have tabs. The kernel has a certain amount of code to work out what column it thinks you're on, and then back up an appropriate number of spaces with Ctrl-H's. By the way, the kernel assumes that tab stops are every 8 characters. Then we have the case when you quoted a control character while entering it by typing Ctrl-V, Ctrl-H. This causes the kernel to print the Ctrl-H instead of acting on it, which is the whole key here, and which, interestingly enough, is a fairly similar abstraction than having a representation of your computation and then the execution of your computation. So like Comomads and like interpretation, or like free monads, not Comomads, free monads. Okay, I want to try this Ctrl-V, Ctrl-H thing. Test, Ctrl-V. Okay, well, yeah, exactly, that pastes. Oh, well, it pastes because I'm on Windows, and maybe it shouldn't paste in general. So we can't really test that. But what? It prints it as a 2-character sequence, blah. When you hit backspace to erase that, of course, you want both printed characters to be rubbed out. Oh, right, okay. So maybe if I do test blah h, no, that's not this either. Okay. You want, so the kernel needs to keep track of that and rub out 2 characters instead of just 1. A final complication for some kernels, a multi-byte character with a display width bigger than 1. Yeah, because some kernels try to handle this. Well, I'm glad they do. It's part of internationalization, isn't it? These kernels get to go through interesting gyrations. You can see an example in Illumo's LD term. FreeBSD also handles backspacing a space specially because you don't need to actually rub that out with the backspace B sequence. Oh, all right, backspace backslash B space backslash B sequence. You mean Control H space Control H, right? But I guess it's equivalent somehow. Other kernels don't seem to bother with this optimization. Right. TTY disk. If you want to see the kernel's handling of backspace in action, you usually can't test it at your shell prompt because you're almost certainly using a shell that supports command line editing and read line and so on. Command line editing requires taking over input processing from the kernel, and so such shells are handling everything themselves. My usual way to see what the kernel is doing is to run cat dev null and then type away. Huh. Okay, let's try. Can I do Control V? No, I can't, right? Because I'm actually not really in the a Unix, and I'm getting a whole layer of interpretation already with that. So that's definitely not working, right? Oh, tap's working though. Ooh, sort of. No, it's not. In fact, test, tab, backspace, exact. Oh. No, it doesn't work anymore. I can't backspace more than this. Strange things, but the layer of being inside VS Code, inside a VM, inside an Ubuntu thingy, that's obviously messing with the character input. Okay, have we really learned anything here? Backspace. Rub out. Rub out is a term of art. I didn't get that. Kernel TTY line discipline rub out. So this is a thing. Okay. Makes sense. Backspace on terminal. Rub. Okay, let's see this guy. It's about behavior of the backspace character. I have the following C program: printf hello bb. Yeah, what is it? Okay, that does work. Oh, okay. Well, you're doing multi-threading in there somehow, I think. Line buffered. Is that why? Where is this O coming from? Hello, backspace twice. We do HLL, sleep 5, and then printf H. And then why would that show O? Oh, I guess it would show O if the interpretation of \b was making your cursor move back twice instead of the interpretation as it's listed here, which is to actually erase what's underneath and then do Control H. Okay. Until everything sprints only after the 5-second sleep. Okay, well, yeah, that's because of the buffering. Okay, if I remove the line H blah, it prints hello and goes back to character without erasing, yeah. Because of a non-destructive backspace. Why is this behavior different from input and output? That is, if I input something into the terminal, even the very same program, and press backspace, erases the last character and not for the output Y. No, the output of your program to the kernel is line buffered. That's the default behavior for stdio when stdio is terminal. And so you need to set the buffer to null to turn out output buffering. Yeah, that makes sense. Because the new line character just moves the cursor and scrolls the screen. Okay, yeah, it doesn't print as a visible character. It would take up the place of a glyph on the terminal. the O should have been replaced by backspace N. Yeah, no, that makes sense. It doesn't do that. It just scrolls. I mean, I guess in this world where backspace also only moves the cursor non-destructively, but I don't know indeed why it does that. What happens depends on what mode the terminal is in. Yeah, indeed. Several modes. Move the cursor, not the text. I mean, so in my representation here would be pink with 2 Ks, if that's how it's interpreted. That's a pretty good thing that I don't know. A terminal is at the end of an electric wire. A shell is the home of a turtle. TTY is a strange abbreviation and a console is a kind of cabinet. Good one. In Unix terminology, the short answer is that terminal equal TTY equals text input output environment. Console is the physical terminal and shell is command interpreter. Input: the terminal converts keys into control sequences. The shell converts control sequences into commands. Okay, that's useful. So in an editor, I would type, let's say, backspace, and it will issue a control sequence. And then the shell would convert the control sequence into going backward, or in my case, backspace. I kind of want to see what the, I don't even know how you pronounce this, the C editor, which is being rewritten in Rust. Wow, I had no idea. And I was thinking of it because I know the Haskell version, but they've dropped Haskell. That's what's been going on. I've been confusing it with E. Okay. I think no link to no link to the code base. Check out on package. Right, so rope is their underlying data type. And let's go check that one out specifically. Let's look at what the text look like. Working with eString is just like working with text, but are interspersed, not like to intersperse. Okay, I see. So it's just maintaining parity, feature parity with text package and comparing the things. So we're not gonna have, it's not unit tests or tests of the internal. Let's look at this rope. Now it has chunks. But really what I want to look at is the interface between the rendering of something stored as a rope and a screen, and then between the typing of a character and both the screen and the data structure. So let's go to the core. That seemed like it's mostly for installation. So maybe it's in the core. And let's check out tests. Completion tests. That sounds pretty advanced. Common tests. Match is a simple shebang. Okay, that doesn't sound like very low level stuff. Front ends are responsible for rendering the editor's data and passing user events to the core. That sounds exactly like what I want to know about. Except there's probably an abstraction that takes a front end, and maybe that's what I need to look at. But let's take a look still. E front end VTI, front end, and just a re-exporting thing. It's not. Base VTI configuration. So a UI boot takes a config, takes some events and actions and the editor. Do we import rope here? We do. And so where do we use it? R dot run buffer. Maybe I should check out Rasa as well. Which uses eString. Opaque reference to a buffer. Show instance. Text focuses the text of the in-scope buffer, but that returns a eString. Which is just a record of the eString rope. I mean, eString is the rope, isn't it? Let's just double check that that's the case. Europe is Europe, it's not eString. Europe. Okay, Europe exports eString. Okay. Okay, maybe I should take take a quick look at this doc. A rope data structure for using E. The specific implementation uses a finger tree with text. In contrast to our implementation, we can now reap all the benefit of text, automatic Unicode handling, and blazing fast implementation underlying strings. This frees up from it sounds like something I should know how this works to be able to do a good job with text implementation with Chronofold in PureScript. This frees up from a lot of the bookkeeping. We don't lose out on not using byte string directly because the old implementation encoded it into UTF-8 anyway, making it unsuitable for storing anything but text. Okay. E-string is a finger tree with cached char and line counts over a chunk of text. Let's take a look at the declaration. Finger tree, keeping the size of chunks. And that's from finger tree package. Yeah, data.finger tree. Let's take a look at data.finger tree. Package. V, a measure type V, used to specify a position in the sequence for the split operation. Okay, yeah, so oh wow, and that's a pretty involved. It's a coordinate system, isn't it? Some sort. Yeah. It does the line splitting. Huh. Very interesting. Okay. So it's a finger tree that you can index with, where you can index any given character with a size which, or an index which specifies how many characters are there from the beginning and how many lines are there from the beginning. Okay. Okay, no, that's all good. And then the question is, so we store one of these in a buffer and we can lens into it, and when we do so, we get back a E string. You know what, maybe I should look at Rasa because I think this was Chris's first text editor too, right? So let's look at E. Okay, so one of the things we do here is that we run a buffer on some window. What is run buffer? Probably from E buffer. And that will be here. Okay, execute a buffer M value on a given buffer and window. The new state of the buffer is returned alongside the result of the computation. Fix a window, an F buffer. What's an F buffer? maybe something that's in here. I need to duplicate this. Maybe not. Buffer implementation is fbuffer here. Fbuffer data seems like it is, but not fbuffer. So maybe it's in normal. Fbuffer. No. Okay, search for it. In MISC. Okay. Hold on, that's where I was. So I just missed it. Yeah, I just missed it. Not this, not this. I am not seeing it. Buffer. Ah, no. No, I can't see it. But yet. Hold on, hold on. Let's try and find it. So it is in core, I believe, right? Buffer. Let's try and find it in the index. F buffer. E types. F buffer. Okay, but I'm not going to read the code here. Instead, I mean, instances are interesting, but it's in E types. You can't go to the definition yet with these things. I'll keep this on, and I will go back to master and go to source and types. And we have fbuffer right here. Okay. The buffer mode. The rule buffer. And some attributes. That's the rope. We can actually get the file path out of a buffer. Where is that stored? In attributes. There's lots of stuff there, and this updates that we've seen in this buffer. Ooh. That sounds scary. Workaround for broken write-a-t. Oh boy. Where do you get the file? Ident A. Is there an ident? Oh, ident. Okay, so that's it. That's ident. And I think that the A is because the lenses are done with a suffix on attributes. And so you get the file buffer out of that. And if it's a mem buffer, then you get nothing. Okay. So it means that, is that right? Where is file buffer? Yeah, buffer ID is either a mem buffer or a file buffer. Okay. So let's go back to my question. Maybe I should write this in the log. Looking at the how do text editors deal with backspace characters architecture-wise? That's the main question. And so, of course, if this is like Vim-like and I'm in insert mode and I hit backspace, then that's something that we kind of want to look at, right? So maybe now we can look at the front end and maybe we can understand what's up here. There's a render loop, it makes sense. It uses mvars for multi-thread synchronization, presumably. And what does he do in the render loop? I think this is what we want. That's the payload. We read the editor. We launch refresh on it. And we do it again. So I think refresh is sort of what we want. Refresh, front-end state, an editor, and then execute some action. So that's definitely an interpreter in I/O. But what is front-end state? Ah, I see. So there's two things in here. In that render loop, there was fs, and so it passes those two things, editor ref and fs. And how is fs built out? Fs is front-end state of VTI that is redone. It's in a let statement, so I think it closes over the rest. Well, yeah, especially because it's here. So it actually packs all of these mvars and represents the current state, I imagine. So VTY would be where we get our keyboard events. And input and main and render maybe are also like events in some ways to quit on something. Dirty must be a flag to say whether we need re-rendering. And editor ref is the editor ref, and for some reason we're still passing editor ref and front end state to refresh, even though it's an editor, not an editor ref. We read the IO ref of the editor ref, so presumably this is the same one, and so that means that we should be able to get away with just a front end state there and no editor. So that's maybe one is the state before. I don't know. Let's look at the implementation of refresh. We have display bounds. We display stuff, including images, status bar, cursor position, and I think VTY actually has, it has the concept of cursor, so we're interacting with that. And then we say VTY update, giving it the front end state and running fs VTY on it. Then somehow saying where the cursor image is going to be. I don't know where the text buffer is in that. And when we say fsvty, yeah, it's just an access, a getter for this record. So nothing special. So where do text update occur there? Maybe they occur in a different thread, because I'm saying that main is doing some stuff in there. Label thread, refresh, render window, find buffer width. Oh, that's it. That's it. Render window gets us into the main window. Passes the config. What is fsconfig? It's config. What's a config? Well, let's assume we can proceed without knowing that. And then E is the editor. Rect is rect is the dimension of the containing window, and NB something related to that as well. And then we pass when that's a whole bunch of let statements, but where is that thing executed exactly? I don't. Pixel layers, command watch big images. Big images is Windows and images. Windows and images is WinImage, and WinImage is that thing. Okay, so big image is where we're executing this code. And WinImage executed with W and F. So I suppose that state really is in the editor here. Let's see. E, we have the rectangle. We get the config, the editor. Our NB is neighbor, and Windows, and some Boolean, which tells us whether we have focus or not. And then we pass a rendered data type, knowing that all this would be then passed to the VTI thing. So the render data type must be the way to describe rendering actions to the VTI front end. And we pass it VTY translate XY of probably this thing, or picked is probably the main thing we're interested in here. And picked is built up at the end, probably from all that precedes. And indeed, this is where we use R and where we get, so we split line and H prime, H minus off, or split at line, so that's the line number, and then stream B then would be maybe some kind of streaming buffer. What is stream B? Take the window worth of lines. We now know exactly how much text to render, pass, and stroke. Run buffer winb and some stuff. Now we run buffer winb and point B. So clearly lots of stuff's going on in the buffer monad with run buffer. And we get a text out of this. We use from mark point, which if not mini, well then first run buffer winb use mark point A from M. So indeed, anyway, I think in the end we take that text and just put it in the... We don't actually. Rendered is... okay, picked. Takes rendered, and rendered seems to be adding buff data. And it seems like maybe that's... Yeah, okay, R2 string text. There we go. And that's probably a buffer in the VTY sense. That it's zipping from mark point. So it's annotating what each, well, actually each character in this case, because R2 string is going to be an array of characters. And that's going to run some operation in the monad every time. Not sure about that. But it seems like really pretty much everything happens in run buffer. But at the edge, at the end of the world here, we take the string we've gotten from the buffer identified by B in win, and we get only what we need out of it, and then we package that up for VTY. So that's all fine, but so one question seen from this perspective would be, would the buffer include the backspace characters? And what if it does? But another question would be, what on key press, what occurs? Oh, there's a whole draw text thing too. So let's see, draw. Yeah, okay, rendered is actually draw text, right? And that takes the buffer data, all good, but that's the drawing occurs here. Takes data to draw here as buff data. It can render line numbers if you wanted to. That's the VTY rendering DSL. Add space, wrap line. Color strings in line separated by backspace and char. Note that we remove the new line entirely since it is no longer significant for drawing text. Yes. But it wouldn't do the same for a backspace character, it doesn't look like. So okay, that's the drawing and the rendering. I'm okay with that, but where is the event handling for key presses? I mean, this should be part of the front end, right? Conversions, what's that? Yeah, so from VTY, it's transformed into a Y event. So when does this occur? Not here. Okay, I see. So we need to find when does from VTY key occurs. Let's stop it. Okay, it looks like that what we're interested in fact is from VTY event. Okay, and this was in here, I just didn't see it. There we go, get event. Read a key, UI needs to define a method for getting events. Yeah, of course it does. We get an event. If it's resized, we do some things. If not, then we do the conversion thing. And then what do we do with get event? We have an input loop. We get the event, and then we check whether there's other stuff. If there isn't, we submit. What does submitting means? It's a callback. Which makes sense. So we need to follow that. Who calls start, and what does it use as the submit event callback? Actually, is start called here? Is one first question. It's exported. Maybe it'd be easier if I look at who imports this. Yep. Don't give me YAML, give me Haskell. Import front-end. That's the default. I think that's what we want. And it's some kind of wrapper. What is plus equal? Lens micro. Okay. Let's double check what a UI boot is meant to be, by the way. Probably in types, no? Evoke, header, core, types. Yeah. So that would be probably another way. And so that's our callback. A list of events to IO. But let's search for configure VTY. Main.hs starts with configure VTY, and then main also starts with configure VTY. Oh, with some build macro thingies. So those are configs. So let's see. That's what it creates front ends. Look up F in the front ends list. And click parser, show version. Run config m. Gets us a config, and then we start the editor. Okay, so run config m. Configuration monad, it's a state T monad. run it with default config. Hey Juan, what's up? Yeah, some while back. Oh, is there no music? Yeah, I was. How about no? I don't have a good way to estimate what the volume is going to be. I don't know if I changed something, but I know. Yes, absolutely. It's definitely a collaborative endeavor. And I go. Oh, I do have some water here, so that's good. Your help is much appreciated. Yeah, and I did take some notes about monitoring the sound from the pretzel player. What's up today? Well, you know, I did like a 15-minute stream or something with no sound at all, so that was a big win. but I was continuing with this this problem that I had identified with the documentation for this library I'm using. You know, a tangent I was following, and I figured out what was going on thanks to the help of the maintainers. Hey, well, I guess then there would be sound in that video, but it's okay. It wasn't super important. But yes, it would have helped. But I started a bit early. So yeah, and the basically what's going on is that the whole community is sort of moving from one way of publishing documentations to a new way of publishing documentations and packages. And so that's why some of that stuff is actually not working properly. So we'll just have to be a little bit patient. And that's all good. And then what I was doing now is I was looking at some of I'm trying to figure out how do other editors do one of the things that I'm doing, and specifically how do editors deal with the fact that maybe that backspace is not necessarily just a key press. Yes, indeed it is. That hitting backspace in my case, because we're kind of keeping track of backspace not just as the action of removing the last character, but actually as the action of adding a backspace character to our data structure. And I wanted to see how other text editor, whether other text editor dealt with that in some way that I could get some inspiration from. And that got me into indeed like a pretty deep rabbit hole, including opening some links on like Linux kernel and BSD and Idiom OS and how they deal with pressing backspace. And now I'm looking at this kind of big code base of a Haskell text editor and trying to see whether they deal with that issue and how they deal with it, if they deal with it at all. And yeah, so you know, less writing code and more reading code on this session. And yeah, it makes me think I should also just try again looking for backspace in the code base. Snippet, KZRP backspace, mix mouse pango, give them. Oh, right. We did find out that there was an event type in here, and that this converted the backspace character BS here into event KBS. So if we look for KBS, I think maybe we will find some interesting things, hopefully. So that's the thing that we're looking at, and so it can create a char, so that's fine. That's the Vim emulation mode, I believe. And fuzzy open, I have no idea what that is. And what is this? Diode? I don't know what this. Dired. Oh, I see. It's an Emacs thing. Because this editor has a Vim mode and an Emacs mode. So is this saying that depending on which mode we are in, things would be different, which obviously makes sense. String to event. Well, event to event string. I'm not sure I'm actually really going to find my answers with regards to architecture. Right, these are Vim shortcuts. Delete word, or 6 times delete word, or 2 times delete 3 words. But this doesn't tell me much about backspace, how it's interpreted. I mean, to be honest, I have some idea of how to implement it, so maybe I should just do that instead of trying to find how others do it. So let's close this rabbit hole by copying all this and closing it and putting it in the log, and going back here. So what would be my idea? Well, we have buffers. And if we think of buffers as what's on screen right now, then maybe we do the interpretation of the backspace manually for a start. So if we do that, right, there's the question of the incremental mutation. Absolutely, it is. Yes. It's all about interpretation. All the way down where, you know, assembly code and are transformed to processor execution, and processor execution is interpreted into electron movement into the in and out of the processor and the memories and the caches, And that, I guess, is interpreted into the fabric of reality, something like that, right? The end of the world. So this is, of course, going to be inefficient if I don't do this in a monad. That's kind of the main thing. So doing it in the state monad, I think really the update monad is really what I'm looking at here. But I think it's not time to wrap this in the update monad yet. I think I'm just going to do a naive project. Where I'm actually, well, let's look at what fold from code point array looks like as code. So script strings. Char. Let's ask for it. Non-empty. We don't need the non-empty one. We want this one. Oh, it's actually a JavaScript function. I see. So let's go to star suit. And look at some, we might want to do it pointwise rather than use this, which is probably faster. But if we want to hook into it to deal with backspace, then I suppose we could do that. No, we want to do it in one scan or one pass. So we kind of want code point to char is really what we want. But none of this is very conducive to that. Ugh. This is quite annoying. This is not, well, this is not done yet, so we can't navigate properly. Okay, let's look at char. And that's the prime char. So no, not that. Okay. This is really inconvenient. Strings. Let's open here, char. Back in from char code. Still not what we want, right? Maybe from enum. Yeah, from enum. And so we just, well, let's try to re-implement from code point array first by calling it from code point array prime and making it a array code point to a string. And calling it here and then folding. I don't know in which direction, but FM2M, yeah, no, that's not what we want. So L, I think, is the right direction, is it? List T, no, not list T, we don't care about list T. This guy. Yeah. So B is our accumulator, right? Yeah. So this would be our function. This is our accumulator, which starts with the empty string, and we pass it CPS. Where go equal takes a B. I mean, really. Oh, right. Well, let's say accumulator and our, well, it's really a B and an A, right? Go takes a B and an A. And gives a B, yeah. So it takes the B and it concatenates it with well, singleton, I guess. Singleton of A. It sounds very well, feels very inefficient somehow, but let's give it a shot. And let's go back to PowerShell and spag or run. Well, yeah, it still works. And so now we can special case our A. Can we? By saying go B. And can we pattern match on a code point with enum? Are there view patterns in purescript? I don't even. Yeah, no, I think we need to do case from enum A off. And say that for all the rest, all the rest will be an A. Do singleton, and then for 8, oh no, wait, that works. A is in scope. Well, in that case, we remove the last character of the string. What's an efficient way to do that? I mean, all of this is not efficient. I get the feeling, but cut points. I don't care about that much. And data string common. Replace split. Split could be cool. Trim, remove white space for no. what's pattern? Using cases where there is a string to be matched. First pattern equals pattern first. Oh, okay, I see. Yeah, that's cool, but that's not what we want. Data string unsafe. Let's see what's in there. Yeah, try and try that. We don't need that. Is it in the... Is it in the main docs? It's a primitive type, so can we do... What's the interface to the primitive type? Is that in the... Let's do purescript string again. Here. Data string... Language prescript type, no. Array. I mean, we don't want to do another conversion. Is there a way in the REPL? I think if I do REPL and data.string, maybe I can use the autocomplete to show me what's in the prelude. Takes a switch time. Doesn't work here. Browse. Show completion. Okay. Complete. That string. Nah. Yeah, my day was good. Thanks. I didn't do much, but I did get to speak to my family, who's distributed a bit across Europe, and you know, this year we decided not to see each other because of Corona things. So it was nice, you know, say hi to my nieces, see what they got for Christmas, and see my parents and my sisters and my brothers-in-law. That was nice. How about you? How was your day? Sure. Yeah, totally. Yeah, we can't get what we want out of the monoid instance of string. Pure script. Okay, I just need to click on string. Is what I need to do. And that's take me to the prim. In which package here? In the prim package. And they're just a JavaScript string, so we really can't do much on it, is what's going on. It's not in code point. I mean, maybe it is in code points. Well, yeah, look, length. Count prefix. Last index of take. And drop. That's what we want. So they are here. It's really not a good spot for these very important functions. But do we need to do the reverse trick? I mean, no, we don't want to do that. That's so inefficient. So we might need to do the split and uncounts, where we'd want unsnock, but we don't have that. So therefore, we need to split. Fine. No split. So we want to split B. At length of B minus 1 of B, and we want to take after of that. Maybe I need to do, will that work? I think this should work, no? From enum, whoopsie, coming from data.enum. So maybe I need to do dot after, and then import this from code points. Oh, it is also in data string. And parenthesis. No, you're not happy with minus. Really? Oh, because I don't have the prelude imported. Okay, and this should be split at should be, oh, B. Why is B not a string? B should be a string. Start with the empty string. Starts with, well, yeah, right, starts with 0 now, so actually, This is not a safe function. So what you think B is array T1, but it's not. So let's write the, maybe it needs the type annotation. String to code point to string. Ah, yeah, of course, because the length was for array, and instead of length from string. So really, we should be prefixing all of this, but for now, we'll just do what? Import data dot string of length as s, and then call this guy s.length. And the types work, and where are we now then? Do we have errors? Oh, well, no, we have just have warnings. So let's run. And well, it displays the same thing, and so now we just need to test it with our naive project on this. Oh, well, hold on 1 second. No, right, we haven't yet added any backspace into this, so let's add a backspace here. And we're going to need to do double backspace, I guess, to escape this. So let's spy on from enum A here. Yeah, spy from debug trace, please. And that's a warning, right? Yeah, it's all good. Okay, that's, I think, is a parenthesis problem. Yeah. Right, so probably the escaping just didn't work. I just need to concatenate backspace onto it. I think that's the better way, right? Okay, and I need to do this and backspace. Okay, K is a bit of a radical thing, but it's the right idea, except maybe it's not after them. So we got our 8, and then we split. Oh yeah, of course, it's not after, it's before. Yeah. Pins. All right. So we have a naive projections that deal with backspace, and I think that's where I'll stop on this nice little win. And it means that now we can deal with backspace, so we're one step closer to making this example work. The next thing we'll need to do is to move to start thinking about how we're going to express the idea of shipping ops to another machine. So then we'll be able to say something like well, we want to think about whether we want to generate ops from an already written log, or whether in fact in reality in the code it's always going to be that we pretty much never use this function. Instead we'll be, even locally we'll be appending ops to the local log, and then as we append the ops by converting, like let's say a key event, if we're in a text editor, convert a key event, we build an op out of the event, and at the same time we can do this in parallel. We can ship the op to the network, and then we can also interpret the op or append the op locally, which will do all the conflict resolution stuff. And yeah, something like that. So let's write it down. We'll probably want to take a keyboard. Okay. Convert a keyboard event to an op in parallel. Send the op over the wire and append the op to the local log. And this will somehow trigger, in some way that we need to think of, the update of the text buffer on screen, which is kind of our projection. And then that will allow us to then make it so that when we receive an op, on the wire, and then we'll just do this part. Something like that. Okay. So yeah, I'll stop here. Thanks for joining. Really appreciate your coming over. Yeah, I'll come back tomorrow around the same time, and I'll also update the Twitch schedule feature. And that's it for today. Take care. Bye bye.